ready to teach you about Bayes theorem, which is really an important topic in probability. So basically, when we estimate probabilities of certain things happening, basically, we have a prior view of their probability and we observe information that changes our view. So here's an example. Okay, we have states of the world. Either a 40-year-old woman with no risk factors has cancer or does not have cancer. Okay, so we have prior probabilities of states of the world before receiving a signal or information about the state of the world. So in other words, a woman 40 years old may get a mammogram to help determine if she has cancer. Okay, and there's a lot of debate whether we over-test on, for instance, PSA for prostate cancer and mammograms for breast cancer. There's a great few books by Gilbert Welch of Dartmouth on this topic. One's called Overdiagnosed, but you may want to read those. They may change your view of medicine. Okay, but let's suppose the prior probability, if we look at a 40-year-old woman with no risk factors of having breast cancer, is 4 in 1,000. And the probability she doesn't have cancer, thankfully, is 0.996. Okay, so those are prior probabilities of our states of the world. And then we get a signal, like we have a mammogram. Either we get a positive test result or a negative test result. And if we get a positive test result, that makes it more likely that the woman has cancer. The question is, how much more likely? Well, this depends on what's called the likelihoods. In other words, how likely is each test result given each state of the world? So basically, the probability of a positive test result given cancer is roughly 80%. Okay, in other words, if you have cancer, there's an 80% chance that the mammogram will come back positive. But often, you'll get a positive test result from somebody who doesn't have cancer, which is, I guess, sort of good that they don't have cancer, but it can scare them. 10% chance. Okay, and so the question is, get a posterior probability, given the positive test result, the chance they have cancer. And most people, when you give this question to doctors with this data, they'll say it's about 67%, 70% chance they have cancer. Well, the answer is it's about 3%, okay? And doctors, if they need to know one thing about math, I think it would be Bayes theorem, because they're always changing their probability of what you have given test results. So now we can use conditional probability and total probability to sort of analyze this problem. Probability of A given B, we know is the probability of both cancer and positive test result. And we want to divide by the probability of B, which is the probability of a positive test result. Okay, now the denominator is the law of total probability, which we talked about in the last video. The numerator is just take prior times likelihood. So everything in Bayes theorem, you're taking prior probabilities times likelihoods. And remember, if I want the chance of two things happening, I can take the chance of any one times the conditional probability given that first event. So how can I get the probability of cancer in a positive test result? Well, I can say I know the probability of cancer, and then I know the probability of a positive test result, okay, given cancer. I've got that right here. Probably a positive given cancer. That's the numerator. Now the denominator, what are all the ways I can get positive test result? I can get a positive test result with cancer and a positive test result without cancer. That's like the engine can fail if it was a flooded engine or not. Probably a positive test result with no cancer. And so the denominator here, basically, we can basically do it the same way that we did the numerator. So we're going to have the probability of cancer times the probability of a positive prior times likelihood, okay? Now the denominator will just repeat that part of the numerator, because probably positive with cancer, I mean, I've already got that, so I can just copy that. And then what's the chance of a positive test result with no cancer? We take the probability of no cancer, okay, and then you're going to multiply that times the probability of a positive test result, the likelihood, given no cancer. And we know all these numbers, so it'd just be a straight plug-in. Okay, so the probability of cancer we have is 0.004. So the numerator, let's get the numerator. It's going to be 0.004 times the probability of positive test result given cancer, which is 0.8. Okay, so that's our numerator. Now the denominator, the first term is exactly the same as this. It's always included. Okay, so that's going to be our friend 0.004, which is the prior chance of cancer times the likelihood, 0.8, and then the second term, the chance of no cancer, which is going to be 0.996, and then times the likelihood of basically a positive test result given no cancer, 0.1. Okay, so that's your denominator. Okay. And so the final answer, as they'd say on Who Wants to Be a Millionaire, okay, the probability of a positive test result, so the probability of cancer given positive test result would be that numerator divided by that denominator. So it'd be this divided by that. Okay, and that's 3.1%, which thankfully is very low. Okay, now there's another way to see this, which is more intuitive and I think people like a lot better. Just take a group of many people. So let's look at 10,000 people. And then we can classify them into one of four categories here. Either they have cancer or no cancer, and we compare that with having a positive test result and having a negative test result. Okay, so now of those 10,000 people, how many would go in positive with cancer? Well, you take all 10,000 of them. Now, how many of them are going to have cancer? This many. And then of those, how many are going to basically have a positive test result? 80%. So that'll give you 32 people there. Now, basically here, you know 40 of the people will have cancer. I mean, take all the people with cancer, that's going to be 10,000 times 0.004. And basically just take away the people with a positive test result. Okay, those will be the people with cancer with a negative test result. So that's going to be 8 people. Okay, now how many people, these are the key, the false positives, will have no cancer and positive test result. Well, there's 10,000 of those people, this many have cancer. And of those people, 10% are going to have a positive test result. So that's 996, that's the key. Okay. Now, basically, if we would take the people with total people with no cancer and subtract that 996, so 10,000 times basically no cancer we'd subtract these guys off. Okay, notice that's everybody who had cancer, no cancer, sorry, and we take away the no cancer people who had a positive test result, you get the no cancer people with a negative test result. Be honest, I don't care about this column. Once I tell you they have a positive test result, okay, then we're in this column. So the question is, how many of these people have cancer out of the total? And the answer is 32 divided by the 996 plus 32. And that is our friend, 3.1%. That's the same answer. So that's a more intuitive approach. But in summary, what you do with Bayes' theorem is you have prior probabilities, you observe test results, you know the likelihood of each test result for each state of the world, and then basically you take the joint probability of the state of the world and the test result you observed, and divide by basically the probability that you'll get that signal, basically positive test result, which is obtained by total probability and priors times likelihoods. So basically, even though there is a positive test result and the test looks to be fairly good, there's a really low chance still they have cancer because of all these people who don't have cancer that test as false positives.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytic stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.